Hello and welcome to an introduction to shader scripting in Unity. My name is Frank, and in this video I will show you the basics by building a surface shader that takes a diffuse, normal and colored specular map. As you can see right now, I only have this basic scene and character that you can get for free on the asset store. To build our shader, we first have to create the shader in the project, and we are gonna name it Bump Specmap. The next thing we're gonna do is assign that shader to the material of our character. You find the shader under Custom Bump Specmap. As you can see, the default is the basic diffuse shader. So to change that, let's open up our shader. The first thing we are looking at are the properties. Properties are all the variables you can publicly assign in the editor. For now we are adding properties for color and an additional texture that will function as our normal map. The next thing we need to do is transfer these properties into the subshader. For that we are gonna create variables with the exact same name as our properties. For the color we are using a half-4 and for the textures a sampler 2D. With everything set up, we can now go to the surface function and build the normal information from our normal map. To do that, Unity provides the function unpackNormal, which takes texture information and calculates the normal vector from it. We get the texture information from the text2d function that takes a sampler 2D and a set of UV coordinates. Now we can take our calculated normal vector and write it into the normal of the surface output. After that we can save and go back to the editor. We can now put the normal map into our material. Please notice that the texture type of that map has to be set to normal. To make our material tintable, we only have to multiply the texture color with our color property and write that into the albedo of the surface output. In order to be able to use a colored specular map, we need to create our own lighting model. To do that, I will first write a helper function that takes two vectors, calculates the dot product of them and returns all calculated values between 1 and 0. The dot product tells you how two vectors are directed to each other and returns values as shown in the graphic. This function will help us with calculating our shading by taking the direction of the light source and the normal of our object. Now we can begin to write our own lighting function. The name of all lighting functions has to start with the keyword lighting and return a half-4. The function takes the surface output we calculate in the surface function, the direction of the current light source, the direction from which we are looking at the objects, and the attenuation of the light source. Note that this function is called for every light source in range of the object. Inside the function we calculate the shading value with our created function. We then use that value to create the shaded diffuse color by multiplying it with the surface albedo and the color of the light source. Finally, we return that color multiplied with the attenuation and the alpha value of the surface. We now created the standard diffuse lighting model. To tell the shader to use it, we have to exchange the keyword Lambert in the first pragma line with the name of our lighting model, without the lighting keyword. Because we wouldn't see any changes now, I will invert our shading value to demonstrate what it does. As you can see, the shadow is now bright and the light is dark. Change that back and we will continue to the next step. Now we can add the specular map. For that we need two more properties, a texture for the specular map and a gloss value with a range between 1 and 4. Once again, we have to take these over into the subshader, where the specular map takes yet another sampler 2D and the gloss value a half. In order to actually bring the color of the specular map over into the lighting model, we have to extend our surface output. So I write a new struct called mySurfaceOutput, give it all the necessary properties for a surface output and add the property gloss color. Next, I replace every reference to surface output in the shader with mySurfaceOutput. I then go to the surface function and save the texture information from the specular map into the new gloss color property of my surface output. In our lighting function, I now calculate the specular value just like the shading value, but with the sum of the view direction and light direction instead of just the light direction. We use that value together with the gloss color and light color to create our specular color. We add that color to our diffuse color and can now look at what happens in the editor when we add our specular map. To get a little more control over the specular, we are going to use the pow function with our specular value and the glossiness property we created earlier. And there you go. We have now created a colored bump specular shader. See you in the next video.